Alright, so, hey guys. So today, in this little video here, I'm going to talk about one of my other projects here. This is a Supermicro FatTwin F617R2 TAC F73. It's a 4U chassis with 8 blades installed to it. Currently configured, it has 16 Intel Xeon E5 2620s. Those are 6-core processors, 2 gigahertz clock. They do boost to 2.5 gigahertz. Those processors support DDR3, 800 megahertz, 1066, and 1333 megahertz. Obviously, ECC memory is supported. Currently installed, there is 256 gigabytes of RAM. I'm not sure what the speed of it is. I haven't really tested this thing that much. As for storage, nothing's currently installed into any of those hard drive bays, but it does have 16 hot plug serial attached SCSI bays, so 2 per node. So everything in this, all these numbers I'm giving off, you divide those by 8, and that's what's obviously in each of the nodes. It was pulled from some environment, who knows where. I think it was somewhere in California, some either a data center or I have no idea what. So what do I need something like this? Well, my projects that I do run on servers, I've gotten to the point where I am pretty much pushing my HP Perliant DL360P Gen 8 server. I'm pushing that kind of to its limits. I think right now it's, well, I think I've got about 80% of the RAM used, and the CPU is just, I mean, it's struggling with all the tasks that I have it running. So it's running a web server, a couple game servers. It runs a bunch of file server support for me for my development stuff. I just need something that's going to be a little bit more powerful. This guy, when I finish upgrading it, which I want to upgrade pretty much every part of it, I'd like to get those Xeon E5 2697s, I think they are, the version 2 ones. I think that's the best processor that you can slap into one of these sockets. Each one of those would, well, it would double the core count totally, currently on board this system. Up to 192 cores, so that'd be pretty spicy. But realistically, I would actually like to try to use this thing to render my videos. I'm not sure if that'll work too well, but we'll see. I'm not really sure where I would slap any of the graphics related hardware, but worst case scenario, I just wouldn't use this for that, but I think it would be kind of cool. I do have that NVIDIA Tesla compute node, so theoretically I could use that to handle the graphics, theoretically, but that, you know, that whether or not there's even driver support anymore, and whether those drivers will support what I want to use them for, I'm not sure. Probably would be asking a whole lot of it. But anyways, let me go ahead here and take one of these blades out, and we'll take a closer look at that so we can get better an idea of what's going on here. Alright, so I got one of the blades out here. So you can see there's not a whole lot of access into it without taking it apart. We are going to take it apart. I actually haven't done this in over a year that I've had this. I have not disassembled any of these to take a closer look, but I think now is as good a time as any to do that. Also forget to mention that in the back here, we did get a little bit of cosmetic dinging here. It doesn't impede the getting the power supplies out. So it's just cosmetic, but it did get boogered up pretty good. I do remember the box having a big dent right about here, and so I could probably hammer that out if I really wanted to, but I'm not too worried about it. Each of these power supplies, though, these are pretty spicy. So let me get out of the reflection of the overhead light. So this is a pretty spicy rating for power supplies. This guy can provide up to 1,620 watts of juice, and there's 4 of these on this system. So to run this with redundancy, yeah, it's kind of an idiotic amount of power that this could theoretically use at a full load. You know, over 6,000 watts of juice. I think it's what, 6,400 watts or so. Yeah, that's a lot. Obviously all these fans are, as you would expect, hot plugs. Pretty beefy fans. Not sure what's... But you can see here with the nodes installed. Let's get this guy out. So there's some space here basically. I'm not actually entirely sure. I think that's just like guide rails to help the blades set in here. But you can see very, very effective cooling. Looks like they actually, these are all the same part number. As you can see, they have this weird bevel here, or not bevel, but cut. So if I was to put this fan here, I would have it like this, and you can see it would go into the correct orientation of the pins. Whereas if I wanted it here, the pins will line up there. So that's pretty cool. Just a nice thing to do if they're gonna have these weird like interlocking fan arrays like this, that they don't require 2 different parts. But yeah, that's all I wanted to show back here, because there's not really anything on the back of this system. As you can see, it's just fans and power supplies. So to get that top cover off, there's just a screw here and then one opposite here. I have those guys out, so we should be able to just pull this off. That is a very light cover. There's our guts. So this is currently configured with, I'm gonna have to look back. Of course, it's not gonna be labeled. I'll be right back, and I'm gonna do a little scan of this code. All right, so I'm actually blind. It just says at the top there, 16 gigabytes. This is actually 1.6 gigahertz memory. So it is actually above spec for the processors that we have installed. You know, if this was pulled from a working environment, then I would presume that these do work. We'll fire it up and test it. But also, I was wondering what this was all back here. This could be a place for some form of expansion, or maybe oh, okay, yeah, we have SATA plugs, so we could yeah, they're all SATA. That's interesting. Is this, hang on. Interesting. These are SATA. This might not actually be SAS. Hang on. Very interesting. Give me a moment. Come here. We can't really. Okay, no, that's I think that's an SAS backplane. Hang on a second. Hold on. Prepared. I knew that this was going to happen. on phone. There we go. Yeah, that is an SAS backplane. So very interesting that they have SATA connections onto the motherboard. Now, to be fair, I've never built a computer with an SAS backplane on it. So they very well may just use SATA connections. The difference between SATA and SAS in layman's terms here, because that's about all the terms I know for it, is that there's a second portion. So you have your power connection and you have your data connection, and then there's another little mini portion in there where these, if you were to try to plug an SAS disk into a SATA port, you'd have a problem because this tooth here sticking down actually gets in the way of that little middle piece that I was talking about. And I guess that middle piece helps to talk with the SAS controller, I think, but I don't know. I'm not an expert on any of this shit, guys. This is all a hobby for me. I've just kind of learned what I've needed to know, and I admittedly need to really learn a lot more. So, but it is really good to see that this has quite a lot of space for memory. It doesn't quite have as much capacity for memory per blade as my Perliant server has, but I think that has 24 slots, so 12 slots per processor. This only has 4 slots per processor. So basically I can fit a third of the amount of memory. But in 4 times the height in the cabinet space, I can fit 8 times the amount of processors. And that's really what I'm running into a problem with. I'm not really running into a problem with memory. I'm running into a problem of processing power. And what I would like to do with all of this is I would like to cluster all of these nodes together and run it in, as a basic supercomputer, a very, very, very basic rudimentary supercomputer. And I think that would be really cool. In a real technical sense, I guess it's not a supercomputer, it's just a cluster, but I think the classical definition of a supercomputer is indeed just multiple computers working together to process the same task. So in that sense, it would be a supercomputer. By today's standards, of course, supercomputers are on the exascale, and this is not even on the petascale. This will have a fair bit of power, though. To put this into perspective, if I was to build a dual socket EPIC build now, which again I've never built a server, so I'm not really super keen on that idea. If I was to build an EPIC system right now, I would have the same amount of CPU cores as this can max out with, 384 threads, 192 cores, with 2 of the 96 core EPIC processors. Now, granted, those are a hell of a lot faster, and the memory that they support is also a hell of a lot faster. But with that being said, 192 CPU cores is 192 CPU cores. So, anyways, so all said and done, there's a lot of space for more storage in this. I don't know if realistically I could ever conceivably use that. Maybe if I could fit 2 and 2 there, maybe, like SSDs. I think it could be possible. Looks like there's no space. Whether or not I could get the cables at the bottom of them, though, and route them along, I don't know. So, but the first thing I want to do is I want to replace all the processors with the 12-core, 24-thread Xeons, the same ones that I have upstairs in my HP Perliant. Those are about $50 a pop. So, they're probably closer to like $30 a pop. But that, you know, I need 16 of them. That's a chunk of change still. Additionally, what are you? Are you a... Oh. Is that a backup CMOS battery? I'm gonna have to look up on the sheet what that is. That's very interesting. I've actually never opened this up, guys. So like this is all like new for me. Like I'm getting kind of excited here because I'm like, ooh, hardware. Because I know this guy here is our CMOS battery. It should be labeled as such somewhere. Sorry for the phone orientation here. And I'm gonna have to look at what all these jumpers do here, because all these are configured interestingly. So we'll have to look and see what's going on with that. Yeah, this is my little cheat sheet, guys, because I have horrible memory and I need something to reference when I'm talking. Oh, one thing I did want to talk about though, really fast. Back it up. If you'll notice on the back of, hang on, I'm gonna try this again. This is gonna be a lot easier. So you'll notice on the front of this, there are an odd number of chips, and on the back there are an even number of chips. I do believe that, let me see where I'm pointing. This guy here, actually let's use this. This guy here is, I believe, the ECC chip for this module, or for this module. That is, I think, is the easiest way to identify ECC memory versus standard memory. Again, somebody can feel free to correct me. I am pretty sure about that, but yeah. I mean, I could look up the part number if you guys are so inclined. See if I can focus this a little bit better. Back it up. So I don't know. I'll look up that part number if I think of it and throw it in. Put a little edit in the video and confirm or deny whether or not that's actually accurate information. Otherwise, somebody I'm sure in the comments can do that. But yeah, so here we have a riser for PCI Express. I do believe PCI Express. I can never remember the orientation. Hang on, let me double check that. I love it when I freaking take a picture instead of a video. I hate phones. I'll be honest, I really need to get some cameras. But this is, in fact, it is in fact a PCI Express. I could be making an idiot of myself, but I do believe, let me get my pen here. There's the notch. I do believe this is power. These pins here convey power. These pins, I believe, are for data. I'm pretty sure about that because it would not make sense for the power to change for different applications. This, I believe, is a by 16, right? I think. And a by 8 would be half of this, and a by 4 would be half of that. And I think they even make by 2s for like the really itty bitty stuff like network cards. Well, the itty bitty network cards, Wi-Fi cards. But it would make sense that those, depending on the pin count, is the amount of bandwidth that you'll have available to that slot. Again, somebody please feel free to correct me if I'm making a dum-dum of myself. But anyways, I always get mixed up. I used to work with a lot of old computers and used the old PCI, not PCI Express, and it was basically a mirror image of this, just flipped over here with the notch. And I don't know if the pin count was the same, but I'm pretty sure it was 16 pins, or well, by 16, 16 pins. That's a lot more than 16 pins. I'm pretty sure it was by 16 size, basically the same size. Anyways, what else was I gonna say? Oh yeah, there is an interesting thing here. I have another PCI Express slot here. And I have no idea what to do with that. Like, why is it even here? Like, what could you even put there? I have no clue. Maybe with a riser you could get something in there, but you know, there's not a lot of space. And you put some memory here. You put some memory there, and problems would ensue. So I don't know. So my plans for this, in terms of just the guts here, replace these processors with the 12-core Xeons. And install memory. I want 64 gigabyte modules. So 4 64 gigabyte modules per processor. So 8 per node. So that's my thought with that. In terms of what else I want to put in here, I think in the short term I'll get hard drives to put in there. Just like probably the 900 gigabyte hard drives that I use. I think they're 12,000 RPM, or maybe they are 15K RPM. No, I think they were 12K RPM. SAS, 900 gigabyte disks. I'll probably do that. But to get these things to operate the way that I want them to, I want these to operate as one system. To do that, I'm going to need to make use of networking. But probably not this networking. And that leads me into the next thing, my planned use for this PCI Express slot. My thought is, can I put a Mellanox card into into each node? They have, I'd have to go dig up the freaking number. Oh, I need to install this memory again. Let me install this memory before I continue here. Hang on a second, guys. Okay, so what I ended up, I had to run and go and double check here on the model. I did get that memory installed. So I ran back up to my desktop to check. So in terms of networking, I want to get I've been looking on eBay, and I've found a couple Mellanox CX455A, the Connect 4, or ConnectX 4, excuse me, cards. They're like 80 to 100 bucks each. But those are 100 gigabit Ethernet. The problem is that they are going to require me to get like the QFSP plus module, and I'm not sure if I have a choice between InfiniBand or fiber. But either way, it's going to be expensive. It's going to be an adventure, I'm sure. But that's my plan. And then the really expensive part would be then getting a switch capable of switching at 100 gigabit speeds, so that I could talk, because those the Mellanox CX455As only have one port, so this would have to go through a switch. And then that gets me into a whole world of networking that I am going to have to really educate myself on, because I don't know the first thing about any of that. So yeah, and then there's 8 of these blades that will talk to each other through that interface. That's my plan. But those switches, they cost like $2,000 to $4,000 used on eBay. So they are pricey, and yeah, so that's gonna be a very much a future thing, because I have some of my own like upgrades for my workstation that I want to do before I even dip into that. So I'll probably cluster these together initially using copper Ethernet. Unfortunately, to get these to really do their job, where they're sharing loads on tasks and accessing memory on a different node and stuff like that, all the cool stuff, it's not really going to be effective. So I'll have to probably configure this, that each blade handles a very specific task, and then network them that way. as individual machines. Probably, I don't know if I even want to cluster it using copper Ethernet. I've done that before in the past with a bunch of old Dell desktops, and it did not run very well, as you can expect, because there's a lot of CPU overhead with these RJ45 NICs. So, anyways, that's kind of my plans for this thing. Some relatively inexpensive SCSI disks, some relatively, nowadays relatively inexpensive processor upgrades. The memory will probably cost me about $1,000 to get all of it. Then the Mellanox cards was probably gonna be about another $1,000. And then the Switch, of course, another $2,000 to $4,000. I'm looking at putting like $6,000 into this single freaking system. But you know what? It beats the alternative. I priced building an Epic server with those two 96 core CPUs, and that would cost me about $35,000. So, for what it's worth, that would probably use a lot less juice than this thing does. But I can't afford that type of hardware. I wish that I could, but I really can't. So, anyways, I think that's probably all that I have for this. Most of this stuff is probably self-explanatory. Like this screw here probably is what releases this, so I can get a card in there. These caddies are relatively self-explanatory. They pull out and you push them in, they go in, and then that pushes the drive into the slot. So feel free to suggest anything, give me alternatives to the idea of using at least the Mellanox CX455 alphas. I don't know what else to say, but yeah, you guys just suggest whatever you want. Give me some ideas, throw me some links to information that might be useful, especially when it comes to networking using the QSFP Plus. I don't know the first thing about any of that. I don't even know if the networking standards are the same, like in terms of how addresses are handled, how any of that, like all this stuff is stuff that I am no expert on. I don't do this for a living. I'd like to do this for a living, but I don't have any formal training. All this stuff has kind of just been a hobby over the years. I'm lucky I got this system for $800. With all this hardware currently installed, it's already a very powerful system. I'd like to make it a lot more powerful. But anyways, let me get this cover put back on, and we'll take a look at it while it's running really quickly and see what we can see. Oh, and how these release, actually, I don't know if I showed this. These guys go like that, and then it pulls out. It's a little lever release. So, see, pretty cool. Okay, I cannot stress this enough, guys. Do not do what I'm gonna do here. So I have two different strips not coming from the same source. This source, I know for a fact, is on a different circuit than this guy over here, because this guy over here is coming out of a GFCI outlet, and that is this is a 20 amp GFCI. So that's the only thing that I am hopeful is not going to screw me here, is that I'm going to run this across two circuits. Also, yes, I am running this in my kitchen. I would not normally run this here. In fact, that's another thing with this server is if I ever run this thing properly, like under load, I have to rewire an entire room with like at least 2 circuits, ideally 4 circuits. And I think I'm just gonna freaking throw in 220 volt circuits. So, and 20 amps on those should not get anywhere near making wires hot and the walls hot. We're not going to do this for long. I don't even know if this is going to work, this matrix the breaker, but we'll give it a shot. Okay, so because these are redundant, we're going to go ahead and I'm going to plug in from the 20 amp first. So, 1. And now, 3. And 4. Do not do this, guys. This is incredibly stupid. So there's nothing to boot, so these are probably just going to go power off. Yep, looks like it. Pretty cool. Alright, so I've set up a screen here so I can take a peek at what's the output on these guys. Do you have anything? Oh, good. And obviously nothing's gonna happen here. Let me repower this, like start this one up from scratch and see what's cooking with that. I should turn off the overhead light. I'm sorry for the glare. Ah, Supermicro. And then I think that gets us back to where we were. Yep, okay. So I'm gonna go ahead and plug my keyboard in. We're gonna find out if my keyboard even works with this because I'm pretty sure my keyboard's USB 3. I'm not sure if that'll be backwards compatible, so. It's not happy. Reconfiguration needs suggested. Okay, then I think that gets us to where we were. Right? Maybe? Oh, now it just reboots. Okay. Let me go get my keyboard and plug that in, and we'll take a better look and see what we can do in here. So we're all hooked up. I mean, my keyboard's lit up. I'm also going to turn this overhead light off here in a second, but that is good to see that they at least seem to have the ability to use a keyboard, at least this keyboard. Alright, so this is where I really wish I had a freaking tripod, so please forgive my shaky hands. Let's see if we can... yeah, we're gonna restart. I really need a tripod, guys, and some cameras. Probably, I actually wanted to get that before I started using this system, or well, made a video on this system, but so that should help a little bit back this screen up a bit. Oh man. So we want to see what our... No, I think that didn't do what I wanted us to do. Alright, let me get this thing into post, or excuse me, into the BIOS. Aha! There we go. Alright, so... Hey. Is it? Oh yeah, that's the second, isn't it? What the f... When did I lose... What? When did I lose a day? Holy f... Hang on a second, is it really the second? Yes, it's really the second. Okay. That is not really... Actually, wait a second, is that... 2200 is 10 p.m. Yeah, that's correct. This time is well, it's close to correct. It's 10 minutes off. So we could fix this. Just let's see. What do we have in here? Interesting. Lots of pretty easy, basic stuff here. The stuff you would expect. Ah, good. Set up for power efficiency, not power or not performance. Probably I will configure this for max performance once I have the power, all the wiring done. But yeah, all right. Let's take a peek at the processors. So here we can see they are the E5 2620s. Nothing crazy, but hey, they do their job. Like I said, I'll probably be putting the 2697 V2s in this. I do believe that's what I have in my HP server. Oh yeah, we already did that. Let's take a peek at our setup here. Aha, okay. So they have these clocked down. Okay. Yep. Okay, so probably what I would end up doing is I'd probably use I have to do some research again, but I think that I will put in LRDIMMs, the load reduced modules. I think that when you have the really high capacity memory, it really puts some strain on the memory controller, electrically speaking. So I think they use LRDIMMs for that. So I'll have to double check that. But again, somebody feel free to sound off down below, because I could very well easily enough be talking out my ass and have no clue what I'm talking about. Hint, hint, guess what? Like I said, I don't do this for a living. This is a hobby. Okay. Oh, that's actually nice. We can set this to stagger the spin-ups, which should help reduce the initial power, I think, as well as maybe vibrations. I'm not sure on that second bit, but I know that probably for power reasons that would be why you would do that. All right. I don't know anything about any of that. Oh, you know what that might be? That might be like my HP. My HP server has an integrated lights out. This might be something like that. It's like a serial. Looking for I don't see a serial port on here anywhere. But it might be one of the 3 ports on the front that handles something like that. I don't know, guys. That's my only real guess as to what Super I/O might be. Yeah, I'm not entirely. I'm not too sure about any of this. I'm not gonna f with any of that. But we don't want to quit yet. So this is for logging. Yeah, they cleared the log before they sold this thing. It looks like. All right, I gotta wrap this up. My phone's gonna die really soon, but yeah, this was indeed set up to run off of a network storage. So that's probably what I will continue, actually. I might actually continue that. If not, I'll boot off of a... oh, I don't know how I want to do it. No, we're not going to with any of that. And then, yeah, so all in all, it's a pretty damn cool system. There's not really anything I can do with it right now because I don't have all the hardware I need, but I'm really looking forward to doing some fun stuff with this system. In the meantime, I really hope you guys enjoyed the video. This was kind of like a exploration process for myself as well, because I had never really set this thing up. I have run it once, but only half the nodes and half the nodes. This time I started the whole damn thing up, which was probably stupid, but hey, whatever. Anyways, if you guys enjoyed the video, I'd really appreciate it if you could drop a like and drop a comment with any feedback that you guys might have. And if you would like to see more content like this or see whatever happens with this system, subscribe to my channel, and I do try to put some hardware stuff in there, like server stuff, what I'm working on alongside my gaming content. But thanks for spending some of your day with me exploring this very, very, very cool system. And I hope you guys all have a wonderful, wonderful day. Take care, stay safe, and I'll see you guys next time.